Okay. Good morning. Good morning, Tarang and Shab. So we're going to continue the same chapter. Electrostatics, and we had actually seen electric potential. We have just got the definition, and now we are going to find out the electric electric potential for a point charge. Okay. So we have to find for a point charge. If you have if you have a point, okay, and this point is nothing but this point is nothing but a q, charge q, okay, plus q. So if I have a point p, so what is the potential, electric potential due to this charge for this point? This is what we are going to find out. Okay. So let us draw the coordinates. So let us see, this is the origin. Let the origin be let the origin at the origin the charge is there, plus q is there, and obviously there will be electric force this side. You know very well this side. Sorry, this is the r coordinate, r distance. If I will say the vector, the distance between from p to q, and obviously the electric field will be directed towards the away from the positive. Yes, we know very well. Negativity inside and positivity is outward. Yeah. So let us see this small part. If this whole distance is r, this small will be dr. Okay. And you know very well the electric potential becomes what? Zero at what? Where? Zero where? Zero at infinite. Zero only at infinite. Okay. Please remember that very well. So if I want to find out the potential, what is the definition? It is nothing but E dot dr. This is the potential from infinite to r. You have to basically, what you have to do, you have to take a charge from here to this point. Okay, infinite to this point. Okay, you have to come this point. So what will be E? You know electric field, it is what? Kq by r square. So we will substitute as K into Q by r square, and then this is dr. Yeah. And why minus? Because you know very well it becomes minus. From infinite it is zero, and when it comes it becomes minus. Okay. So let's put this, and what it becomes, K is nothing but 1 by 4 pi epsilon naught. So this is nothing but minus Q. So Q and 4 pi epsilon naught is a constant term which came out of the integration. What we are left with? We are left with 1 by r square. So 1 by r square dr minus infinity to r. So what is the differentiation of 1 by r square? Since you guys have not studied 1 by what is the integration of this? This basically follows x to the power n formula dx. So what it means? It is basically x to the power n plus 1 by n plus 1. This is the differentiation. So 1 by r square is nothing but, we can write as 1 r to the power minus 2. If you write r to the power minus 2, x is r, minus 2 is n. So it will be r minus 2 plus 1 divided by minus 2 plus 1. So what it will be? R minus 1 by minus 1. So what it will become? Minus 1 by r. So the integration of 1 by r square is minus 1 by r. Clear? Yeah. Anyway, from the next class, if you have any doubt in this class, we will resolve it. So don't worry. Okay. So what will be our integration? Our integration will be, this is there, minus q by 4 pi epsilon naught is there, and this becomes what? 1 by minus 1 by r. And you have to apply integration from where? Infinite to r. These are basically lower limit and upper limit. Lower limit and upper limit. So you have to apply. That means you have to, first will be r. So if you apply this one, it will be minus q by 4 pi epsilon naught. If you substitute r in place of r, it will be minus 1 by r. Okay. And next you substitute infinite at r. It will be what? Minus will be there. So minus one is plus 1 by infinite. Okay. This will be a, so 1 by infinite, you know very well, this becomes 0. So what you are left with? Minus q by 4 pi epsilon naught into minus 1 by r. So minus becomes the plus. So your answer is k q by 4 pi epsilon naught r. This will be your potential for a, and you can write this basically 1 by 4 pi epsilon naught what k. So we can write k into q by r. Very simple, very important. So for a point which is r distance from a, if you have a charge which is r distance from a point, okay, r distance from a point, your potential will be kq by r. It's simple. Okay. So now we will go. Let me just see what is there in your question, and accordingly we will go. So next is we have already studied the electric potential due to a point charge. Okay. Next we'll go to yeah, electric potential due to an electric dipole. What is dipole? If you remember, I had this was there in the previous. I mean, in 11. What is a dipole? Dipole is nothing but a. It is basically two charges separated by a distance. If you have a plus q and minus q, always you take opposite charge. Okay, two charges separated by a what distance. Okay, so if you see electric dipole is separated by a distance, some distance. Let us say we say as b. Okay, then we will have a new vector quantity that's called dipole moment, which is nothing but d into the q charge. Okay, qb. In most of the books we write this as 2l. Okay, and this middle point, obviously, if this is 2l, this part will be l and this part will be l. So we write dipole moment as 2q into l. Why? Because the distance between this is 2l, so 2l into q. In most of the books, and remember, this is again a vector. Which one? D. D is a vector. Remember, q is not vector because q is a charge value, but this is a vector. Distance, dipole moment is all are vectors. Clear? So what is it? What is the SI unit and what is we will study? So that obviously it's a vector quantity, and remember the dipole moment is a vector quantity always directed from negative to positive. That means if this is negative, it is like this. Dipole moment. Okay, dipole moment is towards negative to positive. Don't get confused with electric field. Electric field is from positive to negative. But dipole moment is opposite, from negative to positive. Okay. So what is the SI unit? The SI unit is what? So we can find out this is charge and this is distance. So can we write coulomb into meter? Coulomb meter is the what? Is the SI unit. Okay. And we also have other units like d bar, 1 d bar. Okay. So which is not required. So now we will study that if you put the dipole in an electric field, what will happen? Okay, just a intro. What will happen if you put a dipole in the electric field? If you put a dipole in the electric field, okay, this will basically rotate. Okay, this is minus q, this is plus q, and this is the electric field. Electric field is from this side to this side. So what will happen? There will be an electrostatic force, okay, which will pull this side and this one this side, and after some time, your dipole will become aligned to the electric field. The dipole will become aligned to the electric field. This is minus q plus q, and this phenomenon is seen mostly in where? In microwave. Microwave. Okay. Yeah, this is just an intro. So we have to find now what is the electric potential due to a dipole. How much electric potential, if you have a dipole, what is the electric potential we will get? Same thing, we will always treat that this is a dipole. Okay, this is a dipole, this is minus q, and this is plus q. Always opposite distance. And the distance between them is From here to here, this is a middle point, midpoint. Okay, midpoint. Till here to here, it is L. And from here to here, it is L. So obviously the distance this total distance is 2L. And we have a point P, which is, let's say, R distance from the middle point. R distance from the middle point. Clear? The distance between the charges, the dipole is 2L, LL 2L, and the distance to the middle point is R. Middle point to the point where you want to find the potential. Okay. Now, first thing, you know very well, we will consider it. You consider this dipole as point charge. This is a point charge. This is a point charge. So basically, what you have to do, you have to find individually that for this point, what is the electric potential at this point, and at this point, what is the electric potential at this point. Clear? So the electric potential, okay, due to the positive Q from here, positive Q from P is how much? You know very well, V equal to KQ by R. So what is the here? So K into Q. What is the R? The distance from this side to this side is R. This side is L. What is the distance from here to here? It will be R minus L. Why? Because this total is R. This much is L. So what is this much? R minus L. So KQ minus R minus L. Clear? Yeah. This is the due to the positive. So we write as V1. So this is V1. Similarly, V2, it will be what? If this total is, this is L, this is R, so can we write V2 for the negative point charge? For this point, the potential is K into Q by L plus R. Yeah. Why? Because this much distance is L, and from here you total is L, R. So R plus L. So what is the electric potential due to these 2 points? You just add it. That means the total V net equal to V1 plus V2. So KQ by R minus L plus KQ by L plus R. So what is KQ is common? So let us take KQ common. So what I'm left with? 1 minus R minus L plus 1 by R plus L. So what you do? We'll take LCM. Okay? We'll take LCM. You can pause and you can note down. Okay. So KQ is common. So we will take the LCM of these two will be, denominator will be R minus R square minus L square. And here you get R plus L, and here you will get R minus L. So minus L plus L gone. You are left with 2R by R square minus L square into K into Q. We are left with. Okay. So now what to do? I think I made a mistake. No, I didn't make a mistake. So where did we? Okay, sorry, I did a mistake. Why? Because your Q here is minus. This one is minus. Okay, minus. So this will become minus. So here is minus. So that means. So what will happen? Minus L is 2L. R will get cancelled. So we get 2L. So what will get the answer? We will get the answer as 2L into Q by R square minus L square by 1 by 4 pi epsilon 1. Why? This K is there. So now you tell me, if what is this dipole moment? Intro I told you. P is nothing but 2 into L into Q. So this whole thing can be written as P. Okay. So what do we write? We write as this whole thing as Kp. Why Kp? This is K. This whole thing is P. So Kp by R square minus L square. This is the potential, net potential. But what will happen? Remember, this R is actually very big. It is like you have a potential, you have a dipole, and you have a P. So if you see, this is very small as compared to the R. So what we do? We will consider R as very, very greater than L. When you consider R as very, very greater than L, so what will happen? What will happen? This L square will become still smaller. Let's say if L is zero point 0.2. So what is L square? It is 0.04. So 0.04 is still smaller. So we can actually what? Remove it, or rather we can leave it. So we will have this formula as Kp into by R square. This will be the potential for a dipole, for a dipole at a point, which is, and this is called equatorial. Why equatorial? Why equatorial? Sorry, it's called axial. Why axial? Because this is the axis. This is the axis. If you have here, it's called equatorial. Okay. So what is the formula we got? So for the dipole and a point at the axial point, your dipole will be nothing but, so the potential will be nothing but Kp by R square. And what is R? R is the distance from the middle to this P, and this is L, and this is L. Okay, and it's just Q. So you can very well find. Okay, but that doesn't solve. We have to find. This is one scenario. But what if the point is somewhere here? This is called equatorial. 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 And this is called axial. Many times in exam they ask. Okay. Clear? Good. So we'll come to axial. How to, sorry, equatorial. We found axial. We'll come to equatorial. Again, we will consider a dipole. Again, we'll consider a dipole. So this is the middle point. This is minus Q. This is plus Q. Okay, and you have a point somewhere here. It's called equatorial point, and it's called P. So now the distance from this point to this Q is what? Let's say this is X, and this also will be same. Why? Because this will be like isosceles triangle. Isosceles triangle. Why? Because this is exactly at the middle point. The middle point, this side and this side, both will be same distance. And this is X, this is X. So it's the isosceles triangle with both sides is same. Okay. So what is the potential? What is the potential? From this point to this, simple point charge formula, minus KQY, because Q is minus, so KQ minus KQ into X for this one. And for this one, it will be, this is, let's say this is V1 and this is V2. Okay, plus Q, and this is minus Q. This will be KQ by what? X. So what is net potential? V1 plus V2. So minus KQ by X plus KQ by X. What will happen? This will be 0. So the potential at the equatorial point for a dipole is 0. Why? That's all. Very simple. Minus KQ by X plus KQ by X. Very easy. Okay. Very, very easy. But does that solve the problem? No. So what will happen? What will happen? At any general point, I don't think it is there in your book. At any general point, like it might be axial or it might be equatorial. I think it is there. AP by R2. Yeah. Okay. So we have to now go to the next is at any point. That means this is a dipole. This is a dipole. It can be anywhere. Electric point can be here, 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 anywhere. So how do we find? So this is a very important for derivation. I want you to be in my class so that I can teach you, because if I teach you right now, you might not understand. Okay, you might have doubt. So I will teach you once you are there in the class physically. So that will be easy. That will be easy for you to understand. Okay. So see you in the next class. Thanks.